we want to look at the differentiation of implicit function. First of all, a function of the form f of x comma y equals to 0 is said to be an implicit function if one of these alphabets is a function of another. That's y equals to x squared sin x plus 2x cubed sin square x. If we have this to be a function, we decide to represent sin x by y. We're going to have that y will now be x squared into y plus 2x cubed into y all squared, because since this is sin square x. Remember, sin square x is the same thing as writing sin x all raised to power 2. So if we write it like this, this is going to be y equals to x squared y plus 2x squared y squared. And this y here actually is a function of x. It's another function defined in x. So this becomes an implicit function. If we have the equation f equals to x squared maybe sin x plus 2x sin cube x minus 4. If we have this equation, we notice that this can be written as f equals to x squared, this is sin x, plus 2x sin x all cube minus 4. Now, if we decide to represent sin x by another alphabet, let's assume we want to represent sin x by y. Anyway, we see sin x, we replace it by y. We'll now have that f equals to x squared into y plus 2x into y cubed minus 4. So now have that f is equals to x squared y plus 2x y cubed minus 4. This is called an implicit equation, because when you see y in an implicit equation, it is a function of x. I want to prove to you, why do you always differentiate and add the y over the x? Let me prove to you. Before you can differentiate function that is implicit, you need to remember, how do we differentiate using the chain rule? Recall that if y equals to f of x maybe raised to power n, if we want to differentiate this using the chain rule, we have that the y over the x is equals to n, we can call this u, nu into n minus 1 times the u over the x. This is what I'm saying. N will come down, then f of x will be there. Then raised to power n minus 1 times the f of x all over the x. And this is how we have our dy over x. So in a situation whereby you have that f is equals to x cubed y squared, and you want to differentiate and you want to find the f over the x, this means that this y here is a certain function of x. For instance, it could be that y is equals to maybe x squared. This y you are seeing here is a certain function of x. It could also be that maybe y is equals to sin x. So it is a certain function of x. So you can decide to use f of x for that place. So this can be written as x cubed dot, I will now use, since I know that this my y is a function of x, I can write it like this, f of x all raised to power 3. You see, here now, I am now having a product of two different functions. This is a function of x, another function of x. But why this one is chain function? Because it is a function raised to another power. So we can then decide to use equals to 3y squared. And you're asked to find the f over the x. Now, it means that this particular y you are seeing is a function of x. Maybe cos x, maybe sin x, maybe exponential x. Here is a function of x. So you can decide to write this as a function of x. So you write it like this, maybe f equals to 3 into f of x all raised to power 2. No, for you to now differentiate this, it will need chain rule. Where this my f of x is this y, because we know that y is a function of x. So we can say simply. So now remember, from chain rule, this will be 3 is still outside here. You bring down the power using this n, which is the power, into the function, and the function here is f of x. Raised to power n minus 1. Here the n here is 2. 2 minus 1, according to this place, times differential of the function, the f of x, all over the x. Now, since this function was actually called y, we can replace it by the y. And we now have that, but this is the f over the x. We now have that our the f over the x will now be 3 into, this is 2 into f of x raised to power 2 minus 1 is 1. Then dot the f of x over the x. Remember, since our f of x was y, we replace f of x by y. I will now have that our the f over the x is now equals to 3 times 2 will give us 6. We replace this by y. 6y raised to power 1 dot, remember this f of x is y, so it becomes the y over the x. So therefore the answer here becomes, so therefore if f equals to 3y squared, then the f over the x will give you 6y the y over the x. So I want to use this video to show you how this the y over x always come in differentiation of implicit function. Now I want you to go and try this out. Try this question. If f is equals to x cubed y squared plus 2xy minus 4, find the f over the x. Remember, what that means is that this one you call it f of x, so that by the time you differentiate these two places, you can use product rule and then differentiate this particular one implicitly. This other place you use product rule, but differentiate this particular y using the technique of implicit differentiation.